Good morning, good afternoon, good evening, wherever you are. Welcome to today's webinar, Unlock Performance for MongoDB in the Cloud with Lightbits. I'm Janet Lafleur, Director of Product Marketing at Lightbits, and I'm happy to be here today with Sagy Volkov, our Distinguished Performance Architect. As an expert in performance analysis and storage architectures, he'll not only go deep into our benchmarking details, but he'll also share how the Lightbits architecture creates an ideal storage environment for MongoDB. We'll start with a quick introduction to the barriers our customers are facing in their cloud journey and how Lightbits can help break down those barriers by providing a high-performance storage with SAN-like capabilities. Then I'll turn it over to Sagy, who will start with some more technical details about the Lightbits architecture and then move on to the MongoDB benchmarking testing that he's done. The setup, the results, everything. You can ask questions in the question bar as he's going through, and we'll address them at the end. Then he will do some cost comparisons, and we'll include a total cost of ownership, a TCO analysis we did with one of our financial services customers as an example. Finally, we'll finish with a Q&A session and how you can meet Sagy in person if you're going to reInvent. So let's get started. As organizations build more and more cloud-native applications and they migrate more and more legacy applications to the cloud, we're finding they often are running into barriers. Sometimes they're performance, sometimes cost, and sometimes both. This is especially true for people who have performance-sensitive workloads for their mission-critical applications that just can't go down or have bad performance. Or they have a large-scale and virtualized or container environments, and they're starting to hit up against some cost issues. The high cost can often be driven by having to purchase expensive storage tiers to prevent those bottlenecks, especially as the application scales to accommodate business growth, because we all know everybody wants their business to grow. You got to be prepared for it. And at the same time, the native cloud storage offerings don't always provide the data services they need that they may be accustomed to on their on-premises environment, the replication, the snapshots, the clones, more everything that you might need. And that's where, that is where Lightbits comes in. Lightbits eliminates the over-provisioning of expensive cloud storage while it ensures the performance that you need for your storage-intensive workloads. With Lightbits, you'll be able to scale independently from performance, and you'll gain stronger data protection and higher availability. You can break down with Lightbits the direct attached model of cloud storage and get the benefits of like a SAN in the cloud. The storage resources are unified so that you can manage them collectively and increase your utilization. And you won't have any additional charges for provision IOPS. You'll get thin provisioning and compression to conserve that capacity that you've paid dearly for. And you'll also get high availability through synchronous replication, both within an availability zone as well as across availability zones. So it gives you a lot more resiliency with Lightbits. And you'll get unlimited fast snapshots and clones. So your developers will be very happy to hear that. And that all comes at no additional cost. So it's time for me to turn it over to Sagy, who will give you a lot more details on the Lightbits architecture and how that makes everything possible.
All right. Hey, guys. So again, my name is Sagy Volkov. And let's start with a little bit of AWS general Lightbits architecture. This actually will be true mostly also for our on-prem solution and for Azure solution. In general, Lightbits is a software-defined storage solution. So all you need is a bunch of servers or instances, in this case in AWS, that have local NVMe devices attached to them, and Linux operating system. And we are basically a bunch of RPMs that are installed, or a bunch of binaries that are installed on this Linux distribution, and creates basically using software a logical representation of all the nodes or instances in the Lightbits cluster, aggregating the storage from all the NVMe devices, and then presenting that is basically a single storage entity that can be used with many clients in AWS. You can deploy Lightbits either in a single zone or a multi-availability zone. We can see here a diagram of a distribution of the three Lightbits nodes or instances. Each of them is on a different separate zone. 3 is the minimum, and you can grow the cluster to get more capacity, and also linearly extend your performance with the Lightbits. In AWS, we use all sorts of built-in functions within AWS to make sure that the instances and your data is fully protected. If we use automatic scaling group, we use Lambda functions to monitor everything. So if you lost an instance, automatically another instance will start up on AWS at the same zone. And automatically, of course, data will start to spread into that instance. We have also auto expansion functions. So if we're looking all the time at ratio between how much capacity you are using in the cluster as a whole and in a specific node in general. If a certain threshold, which you can actually tune, reached, we will automatically add another node into the cluster. One other key things about the Lightbits, you can choose the number of applications or replicas for your volumes. So they can go between 1, 2, or 3 replicas. And depending on that, we will, of course, for resilient purposes, distribute the volumes and the replicas between the nodes. We, of course, expose all our metrics through Prometheus, and you can view all of it with the Grafana. And all of this is easily installed through the marketplace using basically our own AMI image. If you want to install Lightbits in AWS with your own AMI image, because you have all sorts of patches for security that you already installed, that's easily doable as well. And when you install through the marketplace or yourself, you can either install in a new VPC or in an existing VPC. If you want Lightbits to be in a different VPC than any of your clients, just do some sort of a VPC peering or anything like that. If you want the Lightbits to be installed in your own existing VPC, it's easily done through the marketplace. So now that we kind of know a little bit about the Lightbits, let's start to talk about the test that I've done. The comparison here is between using Lightbits as a storage provider and the highest EBS storage in AWS, IO2 Block Express. So for that reason, I've used OpenShift 4.13. It's the first version that actually that the CSI driver actually supported IO2 Block Express. Used the latest public MongoDB version. Used YCSB, one of the most common workload generators or excuse me, benchmarks to stress a database. And lastly, for the orchestration of where to place all the MongoDB pods, I have a tool that I wrote, I don't know, 4 years ago to stress Kubernetes storage using all sorts of database. It supports MySQL, Postgres, Mongo, and SQL Server, and all sorts of workload generators. And that's how I use to basically deploy the MongoDB pods. The main reason for that is that this tool makes sure that everything is evenly spread. There are no worker nodes that have more Mongo pods or less or anything like that. Let's talk a little bit about the comparison between storage subsystems in here. So the first thing that you should know, maybe you already know, IO1, IO2, and IO2 Block Express are what's called the provision IOPS. That means that you have to decide upfront how many IOPS you want the volume to be able to provide to your client. And it is not dynamically, you cannot dynamically change it. And but you can on IO2 Block Express create another snapshot from it or another volume and copy the data. It requires all sorts of manipulation. Lightbits, in terms of IOPS or the bandwidth performance that we provide, your limit is basically the cluster or what a single node can provide. You can use, of course, QoS to forcefully, by bandwidth, limit volumes. But there is, if you start to use a Lightbits volume in your MongoDB and you start to see that you need more bandwidth or IOPS to it, there's nothing, if you're using QoS, you can just increase that. If you're not using QoS, as I said, the cluster will be the limit. Snapshot, which is always important in the Kubernetes world, there's no pricing for it. There's also, in terms of capacity, hardly any capacity increase for using Snapshot with the Lightbits. It's all free. Use as much as you want. Snapshot are only consuming the changes between the original volume. Your first snapshot is basically, there's not even any kind of a capacity increase. Opposite to anything in EBS, it's all charged. On the client side, probably should have mentioned that earlier. Lightbits, we are the company that invented NVMe over TCP as a protocol, and then donated it, I guess, into the Linux and the community and the network community. Because nowadays, this is the de facto storage protocol to connect with NVMe remotely. Plenty of other storage vendors are moving to use it. So on your client side, the limitation in terms of what your client can consume from Lightbits is basically the network limit of that EC2 instance. On IO2 Block Express, or for that matter, any ABS storage, you're limited by volume IOPS limit. So in IO2 Block Express, it's 256,000 IOPS, and instance EBS limit, which is at the newest instances, is 350,000 IOPS. That is the limit. On the Lightbit side, if you have an instance with, let's say, 100 gig network and an application or several applications on that client that can consume 100 gig, that we will max out what the client can consume. In terms of volume limitation, kind of went back and forth between these two lines. So we already talked about the limits in terms of IOPS. And lastly, price calculation. We license per node, basically per the capacity of the nodes. It's a very simple calculation, and of course, good to remind that everything in Lightbits is a thin provision. So if you created a 1 terabyte volume, only consume 100 gig, that's 100 gig on in terms of capacity, physical capacity on the cluster. EBS or IO2, you are paying basically for the capacity that you created, which it doesn't matter that you created a 1 terabyte volume and only using 100 gig. And you also have to start to calculate the IOPS, the provision IOPS, which is not too hard to calculate, but it's also not easy because the layers of a calculation between the number of IOPS that you are using. So it's very dynamic, sometimes not very predictable. So let's try to explain what the tests themselves and how I ran them. On the right side is the Lightbits cluster. Again, this is not even the largest Lightbits cluster in terms of capacity and performance. I've used 3 i4i 16x nodes, and each of them has 4 NVMe devices attached to them. As I said before, 3 is the minimum. You can extend it or start bigger if you need. And then the OpenShift I've used, there's only one master. It's not showing up in here. It's irrelevant for the performance testing. I got 3 worker nodes, R6 8X, 32 cores, if I'm not mistaken, each of them. And in each of the in each of these workers, I've kind of left about 20% of the resources for OpenShift itself, and then created basically 2 MongoDB pods, each with a CPU count of 12. Memory is 2 gig. Memory is relevant in this case because we are deliberately forcing a low buffer cache to make sure that IOs are going directly into the storage and are not cached. And then each of these, in each of the worker nodes, there were, for each MongoDB, there was a YCSB pod running YCSB, hardly consume any CPU, and a small status pod that I use to monitor all sorts of metrics while things are running. And of course, between Lightbits and OpenShift, our CSI driver, which you can use also on any vanilla Kubernetes distribution. And that is basically the layout. Comparing that with the IO2 Block Express, the left side of the cluster stays the same, using the built-in EBS CSI driver and a bunch of IO2 Block Express volume. There were 2 volumes of 300 gig attached to each worker node with a IOPS limit of 125,000 IOPS. The reason, actually, it was 128. The reason was above that, the MongoDB just couldn't consume more IOPS. So in order to be fair, I did not go all the way up to 256. Which would make the price of the IO2 Block Express very expensive. Kind of tested where the limit is and stayed over there. It's a kind of a good segue to point out, MongoDB itself is not, as a NoSQL database, is not the most performant IO intensive database that you can think about. But it did perform really well in our tests. So now let's look a little bit about the numbers. The purple is the Lightbits throughputs with operations per second from YCSB, and the orange is the IO2 Block Express. Each of these tests ran for 30 minutes in a sequence of 12 cycles, and then so these are all averages of average. And so you can see the difference regardless if we're doing read only, 70% read, 30% write, and so on. Kind of everything around the 30% gap for Lightbits in terms of the performance. Let's talk a little about the cost. The first bullet points in here are the OpenShift cluster. Again, only the worker nodes here are showing up. No reason to calculate the master. And of course, I didn't calculate the OpenShift license because it doesn't impact anything in terms of the performance itself. So the cost is pretty much the same. These instances are actually not on a yearly basis, but the pricing was for on demand. So actually on a yearly basis, both the Lightbits instances and the R6 and the worker nodes will actually be cheaper in the price. For storage perspective, this is these prices are for a monthly fee. So if you are running these 6 volumes IO2 Block Express with 125, 128 provisional IOPS, you pay about $33,000 a month. On the Lightbit side, if you run our cluster, and again, you can also consume that cluster because we can provide on that cluster a lot more than 300 gig volume. So you can easily use that for other applications in your Kubernetes or even outside of Kubernetes. And the price is only around 13,000 per month. So if you do the calculation of how much it's going to take you to run each of these 6 MongoDB databases, you can see the difference, about 3,200 for Lightbits and 5,500 if you want to use IO2 Block Express. These are some numbers that were taken throughout these tests from YCSB in terms of operations that were done. They are basically relate and completely are the same as the graph I showed 2 slides ago. This just hold a lot more information. Few things that I observe during these tests. So when you prepare data for any kind of database benchmark, you do have to consider also the time it takes to prepare the data. A lot of it is CPU work, creating random data, mostly regardless of whatever benchmark you are actually using. And one of the things that I've noticed, again, it's the same worker nodes that are either using IO2 Block Express or using Lightbits. However, it took a lot longer time and also not consistent longer time to insert the data in IO2 Block Express. And one of the I guess kind of given specs of IO2 Block Express is that you are not, for a new volume, you are not getting the maximum performance. You might not get the maximum performance up to 48 hours from the time you created the volume. This is why I have repeated this test, and these tests were repeated in a manner where data was deleted, same volume was used, data was recreated again. In order to to show basically that even on the longer duration, still the insert time, this is where we're not doing any updates. For updates, you need to do some reads, just inserting data. This was pretty consistent. I already talked about the limit in terms of the 125K IO2 Block Express that came from MongoDB, basically. Again, also relate to that, with this number of cores in each of these worker nodes instances, running more than 90 threads for YCSB show no difference. So 90 was kind of the optimal point, and for both Lightbits and IO2 Block Express. That comes back to that MongoDB is a very good database, just not the most performant database in general. All right. This is Janet. This is me.
This is me. Yeah, I just had to unmute. Thanks, Sagy. To show how this translates to a specific environment, let me show you how we did a TCO analysis for a customer in financial services. This customer has over 60 million active digital customers, and they do 10 trillion payments processed every day. So they're one of the world's largest financial services corporations. They have publicly committed to a cloud-first approach, and they report that 38% of their technology spend is currently in the cloud. They turned to Lightbits to support an environment that had a variety of databases. They had MongoDB, but also Oracle and MySQL. And they had about 1.5 petabytes of data stored on IO2 Block Express for this particular environment they were testing us with. Their storage utilization was much lower than they wanted, in part because their DevOps teams tended to over-provision the storage so that they'd have headroom for growth, because this is a very highly growing company. The team of solutions architects at Lightbits and our partner worked with the company's technical team to design a storage solution that would meet the SLAs that they had in place today and also prepare them to scale for growth in the future. After running the numbers, the team discovered that Lightbits could double their throughput and cut their latency in half. And the overall, it's not just about performance, it's also the TCO. With a 3-year term, they could reduce their total cost of ownership by 57%. So after this TCO analysis, a lot of on-site testing, they purchased Lightbits. And you can read more about this customer in a case study on lightbits.com. There's a little QR code down there. And to summarize it all, Lightbits delivers the fastest block storage available on AWS. It's got high throughput, consistent low latency, and it scales with the application demand. With Lightbits, you will get more predictable, lower costs. You'll pay on a consumption basis, not having to provision your IOs or volumes ahead of time. And you may find that you use fewer EC2 instances, which can reduce your database or application licensing costs. I'm looking at you, Oracle, for that one. You'll get the flexibility of being able to scale your performance and capacity independently. And you'll gain some of these SAN-in-the-cloud kind of advantages by managing your storage resources as a pool, plus get the enterprise data services. So we haven't talked about too much, but the thin provisioning, the compression, snapshots and clones at no additional cost. And your Lightbits licenses are portable. So if you have a public cloud as well as private or hybrid cloud, you can use Lightbits in any of those and share licenses. Finally, to prove our value to prospective customers, we're launching a new offer with a risk-free guarantee. We're very confident on this. We are sure that we will be able to provide superior cloud performance at less than half the cost of a native storage solution, and we call it the Cloud Quick Start Kit. It's got 3 simple steps. First, we schedule a 30-minute call. We discuss your workloads, your overall environment. After the call, we'll assess whether we think that Lightbits is a good fit, whether we can deliver the expected performance and cost savings that we put out there. And if so, we'll give you the option of purchasing a Cloud Quick Start Kit. It's like $25,000 to $50,000, depending on how it's performed. And if you purchase the kit, we will test and optimize your workloads and deliver a comprehensive report that shows what you can expect in terms of performance and TCO savings. And if we demonstrate that we can meet that guarantee of superior performance at half the cost, we will give you the full value of that Quick Start Kit toward your deployment. Otherwise, you can request and receive a full refund. So it is a risk-free guarantee. So it's time for Q&A. Let's see, we do have a few coming in, but feel free to add them so we still have time left. While you're typing, we want to let you know that Lightbits will be attending reInvent, and Sagy in particular will be available to meet with you and discuss your particular needs and how Lightbits might work for you. You can email him directly at the email address on the screen, or if you forget that, you can use the Request a Demo feature on the Lightbits website. Okay, Sagy, it looks like I've got 3 so far. Okay, so we talked about MongoDB. This person wants to know, what other databases does Lightbits support?
Well, we are basically a block provider. So any application, any database that requires a file system over an NVMe device or a block device, well, we support it. I did mention a little bit about Mongo not being the most performant in terms of throughput. The gaps that you see in other databases, MySQL, Oracle, are immense in terms of the performance throughput that we can provide versus IO2 Block Express. Way bigger than what I've showed here on this on the slides. Again, with the same reduction in cost for your storage. So Oracle, MySQL, Postgres, and we tested the Cassandra, SQL Server, anything. Feel free to throw at Lightbits and see the results. Use the web the cloud starter kit. I employ you, and try to get and you'll see the big difference in performance.
Mm-hmm. Yeah, and I just want to put in a special note that Sagy is particularly experienced with Oracle. So if you're using Oracle as well as MongoDB, he's definitely the man. Okay, let's see. How does Lightbits compare to other MongoDB solutions like Atlas?
So, Atlas is a comprehensive solution by, I guess, Mongo the company or MongoDB the company. I'm not sure what is the right name. It takes care of more of a cloud only, multi-cloud only solution where you can replicate your Mongos between several clouds, and Lightbits offer storage. So in this case, you will need to, or some provider will need to manage MongoDB for you. However, we are coming up with an offering to also manage Lightbits for you in AWS. We actually already have that option in Azure. So we are not trying to in this manner compete with the Atlas, but Atlas will use local whatever storage the cloud your Atlas is using. So it will have its limitation. Of course, the performance of Lightbits, the comparison or the gap between IO2 Block Express and Lightbits, it's very high. It's even higher on other cloud providers.
Okay, great. Okay, so this one's, how does running Lightbits compare to using GP2 or GP3?
That's an awesome question. Because when we started our journey into the cloud, and AWS was the first cloud that we have kind of created a solution for. We picked the high-end EBS, IO1, IO2 Block Express as our comparison. However, and Janet showed a few slides about this. If you're looking at a cost comparison versus GP2 or GP3 across 1 or 3 years of paying for the instances, we are actually becoming a cheaper solution either for the lower end, or let's call it the regular storage in EBS. One thing you always have to remember with the Lightbits, yes, you can have one giant Oracle that can consume millions of IOPS and transactions connected into a Lightbits, a big Lightbits cluster in AWS, and you will get the same performance as if you got it on on-prem. But the other side of looking at this is that the Lightbits cluster provides basically the IOPS and throughput in general depending on how many NVMe devices and how many nodes are in the Lightbits cluster. So you can also have 1,000, let's say, Kubernetes nodes using smaller applications, smaller databases, using that single Lightbits cluster as the source of storage. And in that manner, you're basically, you don't need to go through the GP2, GP3 route. And in GP3 also you have about a certain level of IOPS. You have a provision IOPS as well, which means, again, you go through the whole exercise. If you need something higher, let's say at some point the GP3, what GP3 can provide is just not enough for your application. With Lightbits, it's not really an issue. Whether you use QoS or not, it is the limit of the cluster, the total limit of performance that the cluster can provide. So you don't have to worry about things like that. Oh, my application is starting to slow down because I'm getting to the limit of GP3. Just doesn't happen with Lightbits.
Okay, so that was our last question for today's session. Thank you to all of you for attending, joining us today. To learn more, you can check out the resources that have been uploaded to our Bright Talk listing for this webinar. And don't forget, if you're going to reInvent, send Sagy an email and set up some time with him. He'd love to visit with you. Thank you to all, and good night.
Thank you, guys.